Yes. Yes, so picking from where we left, I wanted to show you how this one is called a pipette. And this one is a pipette filler. So pipette filler and a pipette. Now we want to place our standard solution because we're dealing with two things. The standard and the analyte. The standard is the known one, the one whose concentration is known. And then we have the analyte. So we are going to place our standard in the conical flask so that we can react it with the analyte in the burette. Now, for us to transfer this standard into the conical flask, we are going to measure 25 centimeters cubic using the pipette and the pipette filler. Now, to use the pipette filler, I will fix it at the end here. Now, like my pipette is written 25 ml, meaning 25 centimeters cubic, and this one at 20 degrees, it will measure that. Now, and then there is a letter B here. That B has a meaning, which I'm going to explain later. So, to fill our pipette, we fix our pipette filler, and then we dip. We squeeze it, and then we dip it into the solution, which is our standard. Then you release it. You release it. As you release it, you can see it is sucking the solution upward. But the end must remain dipped into the solution. So we are filling our pipette with the standard. So there is a mark here. This mark indicates that when the solution reaches this mark, then you have 25 centimeters cubic. But it has gone past 25. So I have to remove my pipette filler, pole, and then I've removed it. So I must release some solutions so that I have 25. To release the solution, I will remove my thumb, pole to relieve the pressure so that the solution can come out. So one, just kidogo. And see it is moving back up to the mark. Sorry, it has gone past. But when it is there, then you transfer it. You transfer it that way. Now, after doing that, you will realize that some solution will remain at the tip. Some solution will remain at the tip. Check the wall of this burette. It is written B. B means blow. So if it has a B, then you have to blow that solution out. That way. If there is no B written, then you don't need to do that. That volume has been catered for. So this one is a pipette. Now we have 25 centimeters cubic of the standard. The standard solution, which is 25, like in our case, so we can say our standard which we have measured is 25. So we have it like that. Down here, we have placed 25 centimeters cubic. Now let's move on. Let's move on. So we have this thing that we call the end point in a titration, a term which we will be using commonly during our procedure here. Now the end point of a reaction is reached when the reaction is complete. When the reaction is complete, the reaction between the analyte and the standard is complete, then that point is called the end point. But how will you know that the reaction is complete? Now, the end point is detected. The end point is detected by use of endpoint indicators. We normally use indicators. And when we are doing acid-base titration, we normally use acid-base indicators. So how do we use the indicator? The indicator is normally, like now this is an example of a phenolphthalein. If you want to use the indicator, we are supposed to place drops of the indicator, whether 2 or 3, in the solution in the conical flask. Like now I can put 2, 3 drops. So that is an indicator. So the indicator, after being placed in the conical flask, when you'll be reacting A and B, the analyte and the standard, what will have happened is that when the reaction is complete, the color of the solution will change. And that one will signal that you're supposed to stop titrating. You are supposed to stop titrating. I'm going to elaborate on that. Now, another term is titer. The word titer. Now, titer is the volume of the solution that ran out of the burette in every titration. So we are supposed to do several titrations, like 3. And when we are titrating, this is how we titrate. We place the standard under the analyte. And remember, there is normally a white tile. This white tile will help you to note the color change. So you'll be running the analyte down and at the same time swirling, drop by drop. As you are doing that, as you are allowing the analyte to come out and react with the standard, you'll be looking at the color change. Immediately the color will change, then you stop. So the volume of the analyte that runs out of the burette in every titration is what we call the analyte. Like in my case here, the volume has changed from 0 to around 12.8. Like now, it is at 12.8. So the volume of the titer here, my titer, is 12.8 centimeters cubic. So that is one titration. You run the analyte until the color changes, then you stop. So the volume that comes out at the end of the titration is what we call the titer. Then we have indicators used in titration. We have indicators used in titration. We can use phenolphthalein indicator. And normally phenolphthalein is colorless it is colorless while in the acid and pink in an alkali. And then in neutral it also appears colorless. Methyl orange is normally pink, and then yellow in an alkali while it appears orange in the neutral solution. We have another methyl orange that we call screened methyl orange, which is red in an acid, green in an alkali, and gray in a neutral solution. Then the choice of the indicators. How do you choose the indicator to use? If you have a strong acid and a strong alkali, you can use any indicator. You can use methyl orange, screen methyl orange. If you have a strong acid and a weak base, it is better to use screen methyl orange or methyl orange. So methyl orange is where one of the reactants is a weak base or a weak acid. Then when you have a weak acid and a strong base, then you need what? Phenolphthalein indicator. You need phenolphthalein indicator. Now, next time we'll be looking at different types of titrations. We have direct titration. We have back titration, or we call it indirect titration. We have double indicator titrations. And then we have redox titration. So in conclusion, in summary, The apparatus used in titration is the burette, clamp and stand to hold the burette. We normally need conical flasks. We need an indicator if it is not self-indicating. We need a pipette to measure a fixed volume, and then we need a pipette filler. We also require a funnel to fill the burette. And another thing is how to fill the titration table. This one we are going to cover extensively when we will be covering direct titration next time. So next time when we meet, we are going to have one trial on direct titration so that you see how it can be done and the calculations that are involved. Otherwise, well, thank you so much for listening. I hope to meet you again next time.